Good morning, children. Last class we have seen about what is meant by motion, then definition of distance, then displacement, velocity, isn't it? So this class we are going to see about when there is a change in velocity. Okay, so that is rate of change of velocity. About rate of change of velocity, what will be the motion of a body and what changes we can observe. So during uniform motion of a body in a straight line, the velocity remains constant. Okay, so what is mean by velocity? Last class we have seen the rate of change of speed with the direction, that is called velocity with respect to the time. Yes, so during the uniform motion of a body in a straight line, the velocity remains constant because there is no change in velocity. It will be constant with the time. So the change in velocity at any time interval during uniform motion of a body is 0, as there is no change in velocity. The change in velocity at any time during uniform motion of a body is 0. But during non-uniform motion, the velocity change with time. Okay, so during uniform motion there will be the constant velocity. There will not be any change in velocity. But during non-uniform motion, what is happening? The velocity will change with time. So the change in velocity at any time interval, it is not 0. It may be a positive value or negative value. So the quantity which specifies the change in velocity is acceleration. Okay, so in this class we are going to see briefly about acceleration. Okay, so the quantity which specifies the change in velocity is called as acceleration. So now we are going to see the definition of acceleration. So, acceleration is defined as a measure of the change in velocity of an object per unit time. Okay, so during non-uniform motion of the body, there will be a change in the velocity of an object, isn't it? So acceleration means what? It is the quantity which is measuring the change in velocity of an object per unit time. It can be derived by the formula acceleration is equal to change in velocity divided by time taken. So, or it can also be described as acceleration is equal to final velocity minus initial velocity. So change in velocity means we know when when there is a motion of body while starting, that is called initial velocity, isn't it? And when it stop, that is final velocity. Yes, so there is a change in velocity during the non-uniform motion of the body. So acceleration is equal to final velocity minus initial velocity by time taken. So it can be denoted by, acceleration can be denoted by the letter A, and last class we have learned final velocity can be denoted by the letter V, and initial velocity can be denoted by the letter U, and time as T. Yes, so we can write as A is equal to V minus U by T, and when we are taking this T to this side, the it can be converted into product. Yes, so A into T is equal to V minus U, and now V is equal to, take this V to this side, so V is equal to this minus b minus u to this side, when we are taking this minus u become plus u, isn't it? So u plus at. So v is equal to u plus at. In this, v is equal to final velocity, u is initial velocity, a is acceleration, t is time taken. Okay, so this is the mathematical derivation of acceleration. Okay, so what is the mathematical formula for acceleration? A is equal to v minus u by t. Now, if it is an accelerated motion, acceleration motion means the acceleration taken to be positive if it is in the direction of velocity. Okay, so if the rate of change of velocity is in the direction of velocity, the acceleration value will be positive. Okay, if it is in the direction of velocity, but it will be negative when it is opposite to the direction of velocity. So the negative acceleration is also named as retardation or deceleration. That means reducing the speed of the body. Okay, that is deceleration or retardation. So negative acceleration is also named as retardation or deceleration, which is opposite to the direction of velocity. But accelerated motion or acceleration will be taken to be positive when it is in the direction of velocity. But if it is opposite to the direction of velocity, the acceleration value will be negative, and it is called as retardation or deceleration. Now, the SI unit of acceleration is meter per second square. Okay, so what is the SI unit of acceleration? Meter per second square. Now, acceleration is a vector quantity. Okay, vector quantity. And now we are going to see about types of acceleration. So there are two types of acceleration, that is uniform acceleration and non-uniform acceleration. Okay, so what is meant by uniform acceleration? When velocity of body changes by equal amount in equal time intervals, acceleration is said to be uniform. Okay, so when velocity of a body changes by equal amount in equal time interval, acceleration is said to be uniform. Example, motion of a freely falling ball. So a freely falling ball, bouncing ball, so it will be changing its velocity in equal amount in equal time interval, isn't it? So such acceleration is uniform, so the acceleration is called uniform acceleration. Okay, so when a velocity of body changes by equal amount in equal time intervals, then acceleration is said to be uniform acceleration. Now, second type of acceleration is non-uniform acceleration. So, here velocity of body changes by unequal amount. Okay, unequal amount in equal intervals of time. Then it is said to be non-uniform acceleration. Example, motion of a car. So, when we are moving a car, some time sudden brake when we are applying, there will be a change in the velocity of a body, isn't it? So so when velocity of body changes by unequal amount in equal interval of time, acceleration is said to be non-uniform. Okay, and example for that is motion of a car. Understood, children? Now here you can see the graphical representation of motion. So first one is a graphical representation of motion. Describe about the relation between the distance, time, velocity, acceleration. Okay, so first we can see the distance time graph for uniform speed. When there is a uniform speed of a motion, the distance time graph for uniform speed is a straight line. Okay, we will get a straight line when there is a uniform speed by the object. Now, second one is distance time graph for non-uniform speed. So, when the object is having the non-uniform speed, how the distance time graph will be? It will be obtained in the form of curve. Okay, here you can see in the picture. So, we will get a graph, curve graph. Okay, graphical form of curve when there is a non-uniform speed. And distance time graph of body at rest when there is no motion, or when the body is at rest, the distance time graph will be a straight line which is parallel to the time axis. Okay, which is parallel. Here you can see in the picture, the graph obtained will be a straight line which is parallel to the time. Now, velocity time graph, which will describe the relation between the velocity and time. So, when there is a uniform acceleration, velocity time graph will be a straight line. So, here you can see the graphical representation of uniform acceleration is straight line. Now, when there is a non-uniform acceleration by the body, velocity time graph will be zigzag line. Okay, we can obtain a zigzag line when there is a non-uniform acceleration. Understood, children? So, I hope that you all understand about this topic. If you have any doubt, you can ask children. Thank you.